In the spirit of this event being fun, I'm speaking to you from the treadmill in my poorly lit basement because much of my research now relates to something all of you are quite good at and know something about, which is walking. So I am a roboticist by training, and so we build walking robots in my lab where the goal is to design and control these robots in a way that they walk without consuming a lot of power and without falling over. And in this particular case, you see there's a flywheel attached to the hip of the robot. Interesting finding in this case, if you bear the penalty of hauling the weight of the flywheel around for stability purposes, you can also use it to minimize your energy consumed on every step. I also work in biomechanics, where we're looking at rehabilitation strategies for individuals who've had an incomplete spinal cord injury. The challenge here is retraining the human motor control system to deal with the damaged sensory and motor pathways of the spinal cord. And so an interesting finding we've had with my physical therapy colleagues is for these individuals who've had incomplete spinal cord injury, simply walking on a downhill treadmill provides sensory information to the nervous system that increases recovery in ways that flat belt treadmill training does not. And then these two aspects of my research come together when we look at wearable robots, such as the exoskeleton you see here. The challenge in this case is to meld the control system for the robot with the human control system, because those two control systems are acting in parallel. And you don't want, as in shown in the middle picture, a therapist, for example, to be required to tell the robot what it is that the human user is trying to accomplish. Similarly, I also work in prostheses, in this case, powered transtibial prostheses, to try to recreate the functionality of the lost limb. In this case, we see a woman walking with a passive prosthesis. The control system of the robot in this case is actually in series with the human, so it's slightly different than the exoskeleton case. In all of these examples, though, the mechanics of walking are fundamental, and we're looking at things like energy consumption and stability.